Hi, my name is Zubin Nawab, and my project is a modular microlab for chemical synthesis. My project is an engineered system that can be used to synthesize a large range of chemicals. The microlab uses a variety of different modules to perform various steps in a specific reaction. The modules can be added, removed, or replaced. I started this project wanting to do chemistry and engineering and learn about those two fields. When developing the project, I realized how the system could be used to help others facing a problem that I also had. So the engineering problem that I faced was that I wasn't able to get access to lab equipment. The Modular MicroLab helps solve this problem by being able to function as multiple pieces of lab equipment, but in a more compact, easy to use way. As the MicroLab is going to be a substitute for lab equipment, it's necessary to compare those two in the design criteria chart. So I compared the MicroLab, lab equipment, and home equipment to modularity, ease of access, price, and usability. I wanted to make a physical prototype. So I used a case study involving the synthesis of acetylsalicylic acid, which is this compound right here, which is actually aspirin. The goal of this case study was to make the modules able to synthesize aspirin just by adding these two reactants, salicylic and acetic acids. So over here you can see this is the cardboard model this is the first one I made. It's just to determine the size. I wanted to see exactly how it would feel in the hand. I next moved on to this hot glue model. It's now made of acrylic. So over here, this is the final one. This one used weld-on. Weld-on is much better because it chemically fuses the acrylic pieces together, just like a weld glue. So yeah, these are the 4 different type of modules I have. This is the intake module. This is the next module. This is the mixing module. It mixes the chemicals together. Very simple. Took a lot of iterations because I didn't know exactly how to do this, and then I realized the simplest design actually worked better than other designs. This is the heating and cooling module. It can be used as either. It has a second compartment to have a specific temperature to allow the chemicals to have a specific temperature because of conduction through the acrylic piece over here and over there. This is the filtration module. It filters the things, and you can either keep the solid. If you're having a solution, you can keep the solid or the liquid. You can choose between them. So yeah. So I'm going to focus on this module over here, the intake module, because it really shows the different things, the different steps I had to take and actually finalize this design. This one actually took one of the hardest to design because it had to do specifically with volumetric measurements, as you can see here. Those are the stoichiometry measurement allowed me to figure out exactly what volume I need to make these two compartments. The salicylic acid should be here, and the acetic acid should be here. So you can pull this, and first of all, the salicylic acid, which is a powder, drops down in here and goes. It's directly above it, so it should go down directly down. And then after that, the acetic acid, once you pull it all the way out, the acetic acid goes down, and it should wash the salicylic acid down. And so the reaction between salicylic acid, this compound right here, as shown in this model, and acetic acid, as shown by this model, is very simple. And you get this compound, the acetylsalicylic acid right here, but you also get a side product of 2 hydrogens and an oxygen, which is water. Just how it looks in real life. So now that I know how to do the reaction of making acetylsalicylic acid, how do I validate my results? So I did 2 different tests. I tested with using a pH test and an iron 3 chloride test. I tested pure salicylic acid, pure acetylsalicylic acid, and I tested also my product. The reason I did 2 tests was to make sure that I understood that I had the right results. This is actually the reaction scheme of what I was doing for the case study, which is the salicylic acid and the acetic acid. So these are some of the equations I made to determine the volumetric measurements of these are the calculations I did, and these are the measurements. You can see the measurements I've added to make sure those compartments, those fill lines up, are the exact amount to how much of the different chemicals you need. So for future use, as I said before, I would probably use different materials. I would also use laser cutting if I were to use acrylic again in the future. So yeah, thank you for watching. This is my project, a modular MicroLab for chemical synthesis.